Figure 5.6 Interest.java. In this example, we're going to use Java's for repetition statement to calculate compound interest over a 10-year period. In addition, we're going to learn a little bit more about output formatting, and we're going to introduce the math class's pow method, which is used to raise a base to a specific power. Now, as local variables in main, we've declared several doubles. We've got the amount variable, which we'll use to represent the amount on deposit at the end of each year. We've got the principal variable, which stores the initial amount on deposit, and we've got the rate variable, which stores the interest rate that we'll be using in our calculations. At line 13, we see the familiar printf statement using the system.out object. And in this case, we're going to output two strings. We've got a placeholder for a string %s, which is going to be used to output the value of the string year. And then we have another %s with the number 20 in between the % and the s, where we will output the string amount on deposit. The value 20 here is known as the field width, and what it does is it specifies how many character positions the corresponding value should take up in the output. And if the number of character positions of that value is smaller than 20, the value will automatically be right justified and have spaces output in front of the value. If you wanted to do left justification, that's easy. You can simply place a minus sign before the value 20, and that would indicate left justification. Now, the other thing you should know is that if the value you're outputting is has more characters than the actual field width specifies, the field width will increase to accommodate all of the characters in your output value. So it doesn't truncate the output, and therefore you need to make sure when you're doing any kind of formatting that you accommodate the largest values you expect to display. Now, our for repetition statement is down here at lines 16 through 23, and any of you who have done C or C++ or C# programming previously will certainly recognize the syntax of this for statement. The for statement is going to combine all of the features of counter-controlled repetition into the for statement's header or first line. Now, first let's take a look at what the requirements are for counter-controlled repetition. We need a control variable that we can use to control the iteration of the loop. We need an initial value for that control variable. We need an increment or decrement by which we can change the control variable so that eventually the loop will stop iterating. And then finally, we need a loop continuation condition that helps determine whether the loop should continue iterating on a given test of the condition. Now, going back here to our for statement, you'll notice that we've got the control variable year of type int declared here, and we've specified its initial value of 1. So that takes care of 2 out of the 4 pieces we need for counter-controlled repetition. Now, one side note before we move on here: when you declare the repetition control variable in the for statement's header, the scope of that variable in Java is just the for statement. So you cannot use it after the end of the body of the for statement. If you try to, you'll wind up with a compilation error. The increment of the control variable specified in the third section of the for header. In this case, year ++ says we want to add 1 to the year. And the loop continuation condition is always specified in between the semicolons that separate the initialization section from the condition from the increment of the for loop. In this case, we're saying that we'll keep iterating as long as the year is less than or equal to 10. Now, the flow of control through the for loop is as follows. First, we sequentially flow into the for loop and execute the initialization section, and that happens once as you first enter the for loop. This creates and initializes the for's control variable year. We then test the loop continuation condition. If that condition were false initially, the loop would not execute, and therefore it is possible to have this loop execute 0 or more times, and the same is true of the while loop. A little bit later in this lesson, we'll talk about the do while loop, which allows you to guarantee that the body of your loop executes at least once. We'll then go into the body of the for statement to execute the body statements, which will calculate the amount on deposit at the end of each year and then print our results for that year. Then once we hit the closing curly brace of the for, we'll jump back to the increment section to add 1 to our control variable in this case, but you can actually modify the control variable however you need to for your specific purpose. And after the increment, we go back to the loop continuation condition to determine whether we need to iterate again. Now in this example, when we do get into the body, we're going to execute the statement at line 19, which multiplies the principal by the result of the expression math.pow with 1.0 plus the rate being raised to the year. So 1.05 raised to the current year will determine the multiplier by which we have to modify the principal so that we can determine the amount on deposit at the end of that year. Now the math.pow function requires 2 double values, and 1.0 plus the rate results in a double value. Now year is an integer value, but an integer whole number can always be used as a floating point number as well. So it will simply convert the value of year to a floating point number. So if year is 1, it will become 1.0. If it's 10, it'll become 10.0. And math.pow will then use its 2 argument values to determine the multiplier. Now you'll notice something special about math.pow here, which is that math starts with a capital letter, which is your hint that math is a class name. And in fact, this is a special method of the math class. It's called a static method of the class. And in Java, whenever you have a static method, you are able to invoke that method by simply naming the class to which that method belongs, followed by a dot and then the name of the method and its arguments in parentheses. And the math class provides a wide variety of mathematical operations that you can use in this manner. Now you know from earlier examples that whenever you want to use a particular class from the Java class libraries, you normally need to import that class. And notice we don't have any import declarations up above the class, specifically at line 3. Now, because we don't have any import declarations, we know that the math class must come from the java.lang package, which is the only package that gets imported for you automatically. I'm telling you that we did not define math ourselves. Recall that when you have multiple classes that you define and they're in the same folder, they are considered to be part of the same package, and therefore you don't need import statements in that case either. But in this case, it's a class that I have not defined myself, therefore it must be coming from the java.lang package. So let's take a look for a moment before we finish the program at the online Java documentation. And again, you can go to this URL so that you can view the documentation online. You can also go back by removing the API and docs part of the URL and go back to the page for Java SE6 and download from there if you would like this same documentation so that you have quick access to it on your local machine. Now, up in the upper left corner, remember you have a list of all the different packages of the Java class libraries, and we're talking again about the java.lang package, so I'm going to go to that package, and when I go to the package it shows me everything from the package down here in the lower left corner. If I scroll down into the list of classes, you'll see that we have the math class listed alphabetically. And I want to learn more anytime I use any class about the capabilities of that class. And in general, we're most concerned with the class's methods. And they always provide a link to the summary of all the methods in the class. So I'm going to jump to that summary. And you can see here, if I start scrolling down, that there's quite a number of math class methods. And in fact, one of those methods is the POW method that we just used. And before you use any method, you should do 2 things really. One is to go look up that method in the online doc set to find out what its purpose is and how it works. And then separately, you probably want to at least scan through all the other methods that are provided by your class that you're looking up so that you can have a general understanding of its capabilities and what you might want to be able to do with that class in the future. Now you'll notice something about all the different methods that you see here. Each one has the keyword static listed before the method name in the documentation. Now anytime you see the keyword static before a method name, that's your hint that you can use that method without creating an object of that class. In fact, the static methods of a class are available to you as soon as the class gets loaded into memory at runtime. So the simple fact that we use math.pow in our main method is going to cause the Java runtime to load the math class for use at execution time. And then separately, that would also mean that you can use all of these other math class methods simply by referring to them with the word math with a capital M, which is the class name, a dot, and then the name of the method that you see here, followed by the appropriate set of arguments. And if you want a more detailed description, sometimes you can click the link for the method and see that more detailed description. It will also tell you things about the parameters and the return values of the methods that you're using. And you can see here that the first parameter A represents the base, the second parameter B represents the exponent, and that it returns A raised to the B power. So let's go back to our code now. And after we calculate our amount on deposit at the end of a given year, we're going to display a line of text that has the information about the what year we're in and also what the amount on deposit was. And again, we're going to do some additional formatting. Here we're saying %4D as a placeholder for the year, and that indicates that we'll output the year in a field of 4 characters wide, right justified. So the numbers for the year will appear right justified underneath the heading year that we output up above, which has 4 characters in it. And then we have a slightly more elaborate format specifier here, %20.2f. So let's talk about that. First of all, %f is the placeholder for a floating point number of type double or float that we want to output, and we're going to be outputting the double variable's amounts value. The comma that we use inside here is indicating that we want the number to be output with its thousands separator. So for example, in the US we use the comma as the thousands separator, but if I were doing this in a European computer, it would output a decimal point as the thousands separator, and it's automatically localized for us. We can also control that with various localization techniques that are provided inside of Java. The 20 is indicating the field width of the value that we would like to output, so we're going to output it in a field of 20 characters wide, and again that will be right justified by default. And then the .2f indicates that for the floating point number we'd like 2 digits to the right of the decimal point. So we're going to output the value of amount in a field width of 20, right justified with 2 digits to the right of the decimal point, and if the value is greater than 1,000, the thousands separator will also be output as part of that number. So let's take a look at the output of the program. When we run the program here, you can see that for all of the numbers we get the comma, because we're running this on a US computer, a comma indicating the thousands separator, and all of the numbers have 2 digits to the right of the decimal point, and they're all right justified underneath the string amount on deposit. And similarly, you can see that all the year values were right justified under the heading year.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than Live Lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live Lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.